Hi, y'all. I want to talk with you about some of the more common fossils of the Ozarks. So, this is not meant to be a comprehensive listing of the fossils, just some of the ones that myself and my colleagues have found more often over the years. And I want to start off looking at this thing. This is a poster that was developed by the Arkansas Geological Survey, and it is a nice little thing showing a lot of these that I'm going to be showing you and some. And they got some nice facts on there. So definitely, if you want to educate yourself a little bit more about fossils, go ahead and go get that poster. So let me close that and go back to our slideshow. And first thing I want to look at is a type of organism called a bryozoan. So bryozoans are really small organisms, and they're colonial, and they have a morphology a lot like a coral. They are these tiny little jelly animals that are filter feeders, and they I believe that they have some of them have tentacles as well. Of course, the jelly part does not get preserved, and what gets preserved is, in this case, this particular type of bryozoan is the stem or the stalk that holds a framework. It branches out all along this spiral, and it holds a framework of this sort of netting, and in the framework of the netting are tiny little holes that the organisms lived in. It's not the only type of bryozoan that you will find in Arkansas, but it's one of the more distinct ones. In fact, the framework branching, or the netting that branches off of there, makes this look really similar to fish vertebra, which I thought it was in part of college until I took paleontology. Here are some more bryozoans. The phylum that they're in is literally called phylum Bryozoa. But this netting here and that netting there could have well been taken from this Archimedes, that type of Archimedes there. And so they did not live in these little windows or fenestrae of the net. They lived in tinier holes that are on the framework of the net itself. Similar sort of thing here. If you could zoom in more on this sort of thing, you would find a lot of little tiny holes. That's where the things lived. They secreted calcite for their base. So because most of these invertebrate fossils secrete calcite, they are as part of their exoskeleton. They are most commonly found in limestone. However, Ozark fossils are found in sandstone and shale as well. They're just not usually as abundant. This is a type of coral that amateur fossil hunters often call a horn coral, because it is kind of shaped like a cornucopia or horn of plenty. We call them rugose corals, which has to do with their growth ridges there, but that is pretty common sort of thing to find. You see a little, that's thing's about almost 3 centimeters long there. So that's an idea for the size. I'm holding one up right here. You can see that that's one that I have found, and it's about 3 centimeters as well. These things were solitary in that this was the home to a single coral organism. However, they did sometimes live in colonies. It's just that those colonies weren't connected to each other. The phylum for corals is Cnidaria. That's Cnidaria. Cnidarians. That's what they were. When I was going to college, they were called Coelenterata. It's been changed to Cnidaria. More types of corals. These are tabulate corals, and they are much more colonial than rugose, but I've seen a lot of these in the Ozarks. You can see these in chert as well. This is the most common fossil in the Ozarks. It's called a crinoid. The phylum is Echinodermata, which is home to sea urchins, sand dollars, and sea stars. They all have a five-fold radial. I'm sorry, not radial symmetry, but five-fold bilateral symmetry. What usually gets preserved in the crinoid is the stalk or individual discs as part of the stalk. There are limestone rocks that consists of almost 100% of these crinoid fragments. Again, these are extremely common in the Mississippian rocks of the Ozarks. Here's some more. There's nothing for scale here, but these look like some pretty good size ones. These are likely, these may well not be Arkansas crinoids. They look the same, but they look kind of bigger than most of the ones I've run into. Again, this was an animal, and what's preserved is what we call the stalk, which is a plant term, but these were not plants. They were animals that looked exactly like plants, and part of the reason we know that is because we still have them today. We still have crinoids on our current seafloor. Also, from phylum Echinodermata, definitely the strangest, in my opinion, looking fossil that you would see is called a blastoid. You see that five-fold bilateral symmetry again, but a blastoid, what's preserved on the blastoid in these cases are not the stalk, but actually the top of it, the cup or the calyx. And to me, they look nothing more than what they remind me of is if a sea star was painted by Salvador Dali. It looks like it's been draped over something. So you'll notice a scale on there. I've seen these, haven't collected many, but they are about the size of about the diameter of a quarter or so. Not quite as big as a golf ball, usually. Here's another phylum, Brachiopoda. And the animals are brachiopods. And there are a few of these left today, although they took a gigantic hit at the end of the Permian period in the world's largest mass extinction. But there are still a few of these left, but they are really common in limestones of the Arkansas Ozarks. They looked just like a clam. They have two valves that open and shut like a clam. However, they're in a completely different phylum from a clam. They're not any more related to a clam than you and I are, really. And the last one that I have a slide for is ammonoid. This particular one is pretty big, but they can be really small as well. You can find something real similar to this that's also coiled that might not be an ammonoid. It would be a nautiloid. Telling them apart is pretty hard for someone who is not trained in and doesn't work with these regularly. So generally we just say it is an ammonoid or nautiloid, or we could just mention the phylum that both of them belong to, and that's Cephalopoda. So yes, these are related to today's chambered nautiluses and today's squids and octopuses and clams and snails. All those are in phylum Mollusca. Class Cephalopoda, but phylum Mollusca. So same phylum as clams, snails, squids. Pretty big catch-all phylum there. That's all the photos I have. You might run across other things as well. If you do, find someone at U of A or NWAC or another college and that can have a look at it for you.